everyone. Today we are exploring sheet metal versus plastic design, the key differences and considerations. Both materials are widely used in automotive, aerospace and consumer products, but their design approaches are very different. Let's break it down. What could be the key difference between sheet metal and plastic design? Firstly, the material properties. Sheet metal is stronger while plastic is lighter and flexible. Next would be the manufacturing process. Sheet metal is processed using stamping, bending, laser cutting, while plastic is shaped through injection molding, blow molding and extrusion. The types of joining methodologies. Metals require welding, bolting or riveting, whereas plastic uses snap fits, adhesive bonding or ultrasonic welding. As an example, in a car body, panels versus interior trims. Sheet metal is used for structural strength, while plastic is used for lightweight and aesthetic components. Right? There are some design constraints for sheet metal versus plastic. The minimum wall thickness in a sheet metal could be somewhere approximately 0.75 to 0.8 millimeter plus. Whereas in plastic, it varies with respect to the processes. The bend radius and the draft angle. Sheet metal has bending constraints while plastic requires draft angles for only mold release. So, for example, sheet metal can have plus 7 degrees draft angle, whereas in plastics we are talking about only even plus 0.5 to 1 degrees. Surface finish and tolerances. Metal parts have higher precision while plastic parts allow more flexibility in its shape. Another example, a laptop body versus keyboard keys. The outer casing, the metal, needs durability, while the keys, which is made of plastic, needs flexibility. How to choose between sheet metal and plastic in design? Strength versus weight. Metals are stronger but heavier. Plastics are light but less rigid. Cost and manufacturing complexity. Plastics are cheaper for mass production. Metal are cost effective for structural components. Thermal and environmental factors. Metals resist high temperature while plastics work better in chemical resistant applications. Let us take an example now again. Car fuel tank design. Older car used to have metal tanks for durability, but modern cars these days use plastic tanks for weight savings and also corrosion resistance. So, the best practices for sheet metal and plastic design could be summarized like: choose the material based on performance, cost and manufacturing process. Optimize the wall thickness to balance weight and the strength. Ensure proper tolerances and clearances for proper assembly fit. Consider environmental impact when selecting the materials, which is very needed during these kind of days. And that's an overview of sheet metal versus plastic design. Each material has its strength and engineers must choose wisely based on the application needed. Thanks for watching and stay tuned for more engineering insights.